In this video, we will learn how angles are defined on the Cartesian coordinate plane and find out how we can define the sine and cosine of acute and obtuse angles using the coordinate plane. So how do we define angles on the Cartesian coordinate plane? Well, we always start from the positive x-axis. For example, to define a 20-degree angle, we start from here and move in an anti-clockwise direction, and this is where we stop. So this angle between the positive x-axis and this line is 20 degrees. Now if we want to define a 65-degree angle, we start from the positive x-axis once again, move in an anti-clockwise direction and stop here. So this angle between the positive x-axis and this line is 65 degrees. Now let's see how we can define the sine ratio of this acute angle using the coordinate plane. We can use a right-angled triangle to help us. First of all, how do we get a right-angled triangle? We can draw a vertical line from any point on this line to the x-axis to get a right-angled triangle. Let's call this point P for convenience. Let's call this point here Q, and let's look at triangle OPQ. In this triangle, PQ is opposite angle theta and OQ is adjacent to angle theta. PQ is obtained from the y-coordinate of the point P, while OQ is obtained from the x-coordinate of the point P. How about the side OP? OP is the hypotenuse and it can be obtained using the Pythagoras theorem. Now we can define the sine of angle theta as the ratio of PQ to OP. This is none other than the y-coordinate of point P over the length of OP, and this length is always positive. We can also define the cosine of angle theta as the ratio of OQ to OP. This is none other than the x-coordinate of point P over the length of OP. Let's now consider obtuse angles. How do we define a 120-degree angle on the coordinate plane? Once again, we start from this positive x-axis and move in an anti-clockwise direction. Here's 90 degrees. So let's go a bit further to 120 degrees. So this angle between the positive x-axis and this line is 120 degrees. Now if we want to define another obtuse angle, let's say a 150-degree angle, once again, we start from this positive x-axis and move in an anti-clockwise direction and stop here. This angle between the positive x-axis and this line is 150 degrees. Now, how can we go through the process of extension and define the sine and cosine ratios for obtuse angles using the coordinate plane? Similarly, we can select any point on this line and call it point P. Let's select this point here for convenience. And we define sine of theta as we previously did, that is, the y-coordinate of point P over the length of OP. In this case, we have found the length of OP to be 5 units, and we can write the sine ratio like this. Will the sine of an obtuse angle always be positive? Let's find out. When we have an obtuse angle, this line will always lie on this side of the coordinate plane, where the x-coordinate is always negative and the y-coordinate is always positive. So when we extend the definition of the sine ratio to obtuse angles, we find that the sine ratio is always positive. In the same manner, we can extend the definition of the cosine ratio we have seen earlier to obtuse angles on the coordinate plane. So we have cosine of theta equal to the x-coordinate of point P over the length of OP. And we can write the cosine of theta like this here. We find that cosine of theta is negative here because the x-coordinate of point P is negative. Will the cosine of an obtuse angle always be negative? Let's find out. We just saw that for any obtuse angle, the x-coordinate of any point on this line is always negative and the y-coordinate is always positive. So when we extend the definition of the cosine ratio to obtuse angles, we find that the cosine ratio is always negative. To summarize, we have learned to define the sine and cosine of acute and obtuse angles using the coordinate plane. We can conclude that for any acute angle, the sine ratio and the cosine ratio are both positive, and for any obtuse angle, the sine ratio is positive while the cosine ratio is negative.